Hello friends, welcome to Risingpearl.com. Today we have started a brand new series 13, where we're learning a great deal on surface areas and volumes. This is webisode number 2, and friends, today we are going to focus on volume of a cuboid and a cube. So let's get into it. Now I would like to refresh your memory about what is a volume of an object. Volume of an object is the amount of space that is occupied by the object, right? So whenever we talk about volume of an object, and keep in mind here I'm talking about object in general, regardless of the shape. It can be a cube, cuboid, a right circular cylinder, a cone, a sphere, anything. Volume, generally speaking, of an object is the amount of space that is occupied by the object. Now what if the object is hollow? So this is actually true if the object is solid. So think like a book. If you were to think about like a cuboid, so think like a book, right? So that is a solid, or maybe a magnet bar, right? Or like a brick. If the entire thing is solid, then the volume of the object is the amount of space occupied by the object. Now what if the object is hollow? That means that it is not filled in. If the object is hollow, then the object can be filled with air or any kind of gas or any liquid. Theoretically we can say, yeah, we can fill the object because inside is hollow, empty, so we can fill it in with any kind of gas or liquid. In that case, the volume of the object can be expressed in terms of how much substance, liquid or gas, we can fill into the object. This is also known as capacity of the object. So think this way: if you have a soccer ball and you want to pump air into the ball, right? So the soccer ball by itself is empty inside. So if you want to find out the volume of the soccer ball, you can measure that as how much amount of air that I can put into the soccer ball. So the soccer ball volume will be equal to the amount of air that we can put into it, right? So just to make this point, so if you have like a book, this is a book, right? So the volume of this book, which is a solid, is really the amount of space this book will actually occupy, right? So on the other hand, if you imagine a room, I have on purpose drawn the room a little bit differently from a perspective view standpoint. So this wall is colored orange, this wall is colored light yellow, and these two walls are not colored. Or maybe you can think of it, we are looking at from outside, so we don't know what the color of these two walls are, right? So this is a room. So the volume of this room, the room inside is empty. So if I were to find out the volume of the room, I can find out the amount of air which is inside the room. That will be equal to the volume of the room, or the capacity of the room will be equal to the amount of air which is inside the room. So having said that now, so what do we mean by volume of a cuboid? So you know from your earlier grades that volume of a cuboid is nothing but length times breadth times height. In other words, if you recall, what we do is we find out the area which is highlighted in blue here, which is length times breadth, and because the third dimension is the height, we multiply the area which is length times breadth, this area highlighted in blue, times the height of the cuboid. So that is how we get length times breadth, which is the area times the height. So similarly, as you can imagine, if it is for a cube, what is the volume of a cube? We know in the case of a cube, the length, if this is A units, so the breadth will be A unit and the height will be A unit. So then if it is length times breadth times height, if length is A, breadth is A, and height is A, it will be A times A times A, or it will be A cube, where A is the measure of one of the sides of the cube.